NASA's Juno spacecraft continues its exploration of Jupiter and its moons. So far, the probe has completed its 66th flyby of Jupiter, the largest and oldest planet in our solar system, and is now ready to share new data and images. Based on the mission, we have once again confirmed that Jupiter's composition is very similar to that of the Sun. Mainly hydrogen and helium. We also discovered that deep within Jupiter's atmosphere, both pressure and temperature increase, causing hydrogen gas to compress into a liquid. This makes Jupiter the largest ocean in the solar system, an ocean consisting of hydrogen instead of water. The probe has repeatedly confirmed the theory that, at a depth halfway to the center of the planet, the pressure becomes so intense that electrons are stripped from hydrogen atoms, making the liquid electrically conductive, like metal. Jupiter's rapid rotation is believed to generate electric currents in this region, with the rotation of liquid metallic hydrogen acting as a dynamo to create the planet's powerful magnetic field. Deeper still, Jupiter's central core has long remained a mystery. Researchers hypothesized that Jupiter is primarily a homogeneous mixture of hydrogen and helium, surrounding a small solid core of heavier elements, such as ice, rock, and metal, formed from debris and small objects in the region of the early solar system about 4 billion years ago. The Juno spacecraft, which measures Jupiter's gravity and magnetic field, has provided data indicating that the core is much larger than expected and is not solid. Instead, it appears to be partially dissolved, with no clear boundary between the core and the surrounding metallic hydrogen, leading researchers to describe it as dilute or blurred. As a gas giant, Jupiter does not have a true surface. The planet is primarily composed of swirling gases and liquids. Although the spacecraft would have nowhere to land on Jupiter, it also wouldn't be able to fly through it unscathed. Rest assured, the extreme pressures and temperatures deep inside the planet would squeeze, melt, and vaporize spaceships, much like cheese in a microwave. Yes, Jupiter's appearance is a tapestry of cloud bands encircling the planet, with cyclonic storms dotting it from pole to pole. The gas giant likely has 3 distinct cloud layers in its atmosphere, which together span 71 kilometers. The upper cloud layer is likely composed of ammonia ice, while the middle layer is composed of ammonium hydrosulfide crystals. The innermost layer may consist of water ice and steam. The bright colors seen in thick bands across Jupiter may be jets of sulfur and phosphate-rich gases rising from the planet's warmer interior. Jupiter's rapid rotation, one rotation every 10 hours, creates strong jet streams, dividing its clouds into dark belts and bright zones in long continuous stretches. In the absence of a solid surface to slow them down, Jupiter's spots can persist for years. Turbulent Jupiter, driven by over a dozen prevailing winds, is a planet of constant motion and ever-changing weather patterns, some reaching speeds of 550 kilometers per hour at the equator. The Great Red Spot, a swirling oval of clouds twice the width of Earth, has been observed on the giant planet for over 300 years. However, quite recently, 3 smaller ovals merged to form a smaller red spot, roughly half the size of its larger counterpart. The latest results from the Juno probe provide a more complete picture of what is happening beneath these clouds. The data show that Jupiter's cyclones are warmer at the top, with a lower atmospheric density, and cooler at the bottom, with a higher density. Anticyclones, which rotate in the opposite direction, are cooler at the top but warmer at the bottom. The results also indicate that these storms are much taller than previously expected. Some extend 100 kilometers below the cloud tops, while others, including the Great Red Spot, stretch over 350 kilometers. This amazing discovery shows that the vortexes extend into regions beyond where water condenses and clouds form, below the depth where sunlight penetrates the atmosphere. The height and size of the Great Red Spot mean that the concentration of atmospheric mass within the storm could potentially be detected by instruments studying Jupiter's gravitational field. Two close flybys of the probe over Jupiter's most famous spot provided an opportunity to search for the storm's gravitational signature and complement other findings regarding its depth. Besides cyclones and anticyclones, Jupiter is known for its distinctive belts and zones. White and reddish bands of clouds that wrap around the planet. Strong east-to-west winds moving in opposite directions separate the bands. Previously, Juno discovered that these winds, or jet streams, reach depths of about 3,200 kilometers. Researchers are still working to unravel the mystery of how jet streams form. The data collected by the probe during several flybys reveal a possible clue. Ammonia gas in the atmosphere moves up and down in remarkable alignment with the observed jet streams. The data also show that the belts and zones undergo a transition at approximately 65 kilometers below Jupiter's water clouds. At shallow depths, Jupiter's belts are brighter in microwave light than the neighboring zones. But at deeper levels beneath the water clouds, the opposite is true, showing a similarity to our oceans. Jupiter's magnetosphere is a region of space influenced by the planet's powerful magnetic field. It balloons out 3 million kilometers toward the Sun, ranging from 7 to 21 times the diameter of Jupiter itself. It narrows into a tail shaped like an interplanetary tadpole, stretching over 1 billion kilometers beyond Jupiter, reaching Saturn's orbit. The vast magnetic field of Jupiter is about 40 times stronger than Earth's. The magnetic field captures a swarm of charged particles and accelerates them to very high energies, creating intense radiation that bombards the innermost moons and can damage anything from alien gadgets to Earth spacecraft. Jupiter's magnetic field is also responsible for some of the most spectacular auroras in the solar system at the planet's poles. Since the Juno probe began exploring Jupiter, it has counted at least 112 moons. But it's rare to encounter any of them, except for the largest ones, of course. Although it's rare, such images do occur. For example, a new image captured by the spacecraft from a distance of 900 million kilometers shows Amalthea, a tiny moon with a radius of just 84 kilometers. In the images, Amalthea is shown above the Great Red Spot. Amalthea is the reddest object discovered in the solar system. It orbits very close to the giant planet, even closer than the volcanic world of Io. Amalthea completes one orbit around Jupiter in less than half a day. It is believed that this moon emits more heat than it receives from the Sun, possibly because electric currents are induced in its core. However, as with Io, tidal stresses caused by Jupiter's gravity might literally fry the moon, much like French fries. As a result, the Galilean moons do not seem geologically dead, like Earth's own moon. This is why Io experiences the full fury of Jupiter's gravity. However, its icy sibling Europa is vastly different. Beneath its frozen shell, Europa is believed to hide an enormous ocean of liquid water. Europa is a primary target for studying planetary habitability thanks to Jupiter's tidal heating processes, which keep it warm enough to potentially harbor life. The Juno probe also found enriched levels of heavy gases, more than initially expected given its current size and position. This chemical clue suggests that Jupiter might have formed farther from the Sun, where it was cold enough to attract ice and frozen gases. Then it gradually moved closer to the Sun until Saturn's gravity held it in place. Jupiter's dusty ring went unnoticed for a long time. Like the rings surrounding other planets in the solar system, Jupiter's ring is a vast debris field. Wreckage from crashed meteorites, asteroids, and possibly even alien ships accumulates around the planet. This loose mix of ice, dust, and rock stretches 210,000 kilometers wide from Jupiter's surface. When other celestial objects pass through the ring, they can leave trails in the dust stream. One of the most famous trails was left by the Shoemaker-Levy comet. A long time ago, it collided with Jupiter, and ripples were later discovered in the planet's ring, stirred up by the comet's debris like celestial footprints on freshly fallen snow. As of now, the Juno spacecraft has long completed its main scientific program and is using its remaining resources to continue flybys of Jupiter, approaching some of its moons whenever possible. The spacecraft continues to amaze mission leaders and the public. Initially, the Juno mission was expected to last only until October 2017, which was enough time to complete 33 orbits before Jupiter's gravity would have pulled it into the planet's turbulent atmosphere and destroyed it. But the spacecraft kept surviving time and again, avoiding any risk of collision with Jupiter's three largest moons, Europa, Ganymede, and Callisto. The next close approach of Juno to Jupiter will take place on November 25th. The official mission of the probe will be completed on September 15, 2025, when the craft makes a fatal dive into the gas giant during its 76th close approach to the planet. But perhaps that will not happen. During this phase of the flight, the orbiter will circle the planet 42 more times. It will explore its moons and complete the first comprehensive study of Jupiter's faint rings in history. After that, we'll see just how much more the spacecraft can achieve. Currently, there are two missions focused on exploring Jupiter that will eventually succeed Juno. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, launched into space last year, will take several images of Callisto when it approaches the Moon in 2031. Later, the spacecraft will explore other moons of Jupiter. NASA's Europa Clipper, launched not long ago, will reach Jupiter in 2030, where it will focus on studying the planet's moons, with a special emphasis on Europa. We hope to learn even more about Jupiter and its nearby worlds.